Okay, we are doing practice number 1. Chang here is going on a trip to visit some friends from summer camp. He used $40 for food and entertainment. He will also need money to cover the cost of gas, and the price of gas at the time of his trip is $3.25 a gallon. So part A, write a function to represent the cost of the trip. So I'm going to do that right down here. So practice number 1. All right, for part A. Okay, your costs here, excuse me, we're going to use C and G. C of G is going to be equal to the cost of gas, so $3.25 a gallon. You don't know how many gallons you're going to use, but we know it's $3.25. And we're also going to have to tack on the cost for food at $40. Now, I'm using G and C of G to represent, again, G for the number of gallons of gas, and then C of G will represent the cost, okay? All right, part B. Identify the independent and dependent quantities. Okay, what's going to be driving everything is, no pun intended, is the number of gallons of gas. And then that is going to influence then your cost of the trip. So the C of G, which is in terms of dollars. Part C, identify the rate of change in the y-intercept. So don't forget our y equals mx plus b, or general form of y equals ax plus b, where again, these are representing your slopes, and this is representing your y-intercept, which in this case is the slope is the 325, and that's going to represent the 325 is the cost per gallon of gas, and the y-intercept is going to be the cost of food if no gas purchased. So that is basically like before you start your road trip and you've done any more gas, you go in to the gas station and get your $40 worth of food. That's what would be happening, and that would be like, hey, I'm not going to do the road trip, but I've already spent $40 on food. So that's the y-intercept, because the y-intercept occurs when the x is 0. Part D, graph the function representing the, okay, on the coordinate plane. We'll talk about that in a little bit. I'll go bring up my calculator here for that, but let's just go ahead on part E. Well, use the graph to determine how many gallons can he buy if he has saved $170 per trip. So we don't necessarily need to use a graph, and I wouldn't probably suggest it myself. I'm going to use the function that we've been building and setting the cost of what we've saved in order to figure out how many gallons we can buy. So I'm going to subtract 40, and I'm going to divide by 130 divided by 3.25, and then what I get for that then is, all right, give me, I guess I didn't get my calculator out. That's going to be, 1 second. I don't have my calculator, so let me get back to this. That's my, getting my phone out. So 130 divided by 3.25, that's going to be 40, okay? Now, so he can buy 40 gallons worth of gas. Now, it then says write it as an inequality. So this is why I was pausing to take a look at. So in that case, okay, the amount of gallons of gas you can buy can be up to 40, but not anything more than that, because you go anything over 40 gallons, you're going to be over that $170 that you've saved, okay? So that's why as an inequality, it looks like that. On part F, verify the solutions I interpreted from the graph. I'm not worrying about that. Part G, his mom gave him some money for his trip. He now has $220 saved for the trip. So what is the greatest number of gallons of gas you can buy for your Renzo Amani? So very similar to part E that we did, we're gonna now set it equal to 220. Now technically, I guess we can go ahead and write this as an inequality, and it's gonna be the, excuse me, same idea, where we cannot go over that $220. It has to be $220 or less than equal to that. So when I subtract 40, I get 180, and 180 divided by 3.25 gives me not necessarily a pretty number here. I get 55.38. So as long as I don't go over essentially 55 gallons, I'll be fine, okay? Again, that's gallons. And then part H, Chang spent more than $92 on his trip. How much gas could he have bought? All right, so for this last one, we're going to continue to say, do this. If he spent more than that, and I wrote my inequality the wrong way, because his amount of money that he spent, which is right there, turned out to be more than $92. So when I subtract 40, I get 52. And 52 divided by 3.25, it means he could have spent at least 16 gallons or more. Okay, I shouldn't say or at least, because he did spend over 16 gallons, because there is no equal to that. So he for sure went over 16 gallons, and that resulted in him spending more than $92. Now, going back up real quick to part E, to just say make your graph. I'm not overly concerned about that, but just as a reminder, as we go ahead and type that in, 3.25, and we use the X button for our variable instead of G, plus 40. We hit graph. It's out the window, as we've done before. We go to zoom, and then we can go not to zoom stat, but to zoom out, or if we go even further, zoom fit. Either one of those will be fine. Just kind of depends on where that is, and because that 40 is way up there, that's what it's going to look like. So not a great graph. That's why I wasn't worried about this one here, okay? So if you're doing your calculator, I'm good to go there, all right?